Okay, so let's analyze our results. Now, I've plotted a graph here. Let me just explain to you how I've gotten from what we measured to what I've actually plotted. So we measured our wavelength. We knew what the wavelength was, but I've plotted the frequency. So the frequency is equal to the speed of light over the wavelength. And the speed of light, that's just 3.00 times 10 to the 8. So I divided this by the wavelength to get my frequency column. Now, what I've plotted on the y-axis is the magnitude of the stopping voltage. The reason why I don't include the negative is the negative is just about the direction in which the voltage is being applied. So it's not important. It's not what we want in this case. What we want is the magnitude of that stopping voltage. Okay, so Einstein told us that HF is equal to the maximum kinetic energy that an electron can have plus the work function for the metal. And we know that the maximum kinetic energy, we're measuring that physically by measuring this stopping voltage. So that's equal to E times the stopping voltage, where E is the charge on the electron. Okay, so let's substitute this in here, and we've got HF is equal to E V stop plus phi. Now I'm just going to rearrange this. I'll write V stop is equal to HF minus phi, and so V stop is equal to H over EF minus phi over E. Now, why I've written it this way is that I'd like to get this equation in the format of the equation for a straight line. So the equation for a straight line, we've got our equation over here, and this just means y is equal to mx plus b, where b, this is the y-intercept, and m, this is the gradient. So now I've put v stop, that's on my y-axis, so this thing here is my y, and I've put the frequency on the x-axis, so this thing here is my x. So equating this with this over here, where I've got actual numbers, is going to give me my values. So h over e is, according to my plot, 3.40 times 10 to the minus 15. Where h is Planck's constant and E is the charge on the electron. So I can actually use my graph here to measure what Planck's constant is. So I've got h is equal to 3.40 times 10 to the minus 15 times E, which is 1.602 times 10 to the minus 19. So solving that one on the calculator, I end up with 5.44 times 10 to the minus 34. And that is in joules seconds. Okay, now it's not perfect because the real value of Planck's constant is 6.626 times 10 to the minus 34 joules second, but at least it's the right order of magnitude. So that gives me a bit of an idea about how accurate that photoelectric kit was. Okay, so we've worked out Planck's constant. We can also work out the work function of the metal on our cathode. So we've got phi over E, that is equal to the y-intercept. So we've got a minus there and a minus there. This is equal to 1.26, and that's volts. So it's probably best actually, rather than converting this into joules, let's give it in electron volts. So this tells us that our work function is equal to 1.26 electron volts. Now the other thing that it can be interesting to work out is the color frequency. So that's the frequency below which no electrons will be ejected from the metal. Okay, so we can look at it where around about that will be by setting up our ruler here. So we've pretty much got a line around about like that, and we're looking for this point here where it crosses the x-axis. So in order to calculate what that cutoff frequency actually is, this is the point at which the stopping voltage, the Y value, is equal to 0. So we set this Y to 0 here. So we've got 0, V stop, is equal to 3.40 times 10 to the 15 x, that's minus 15x, minus 1.26. So we solve this to work out what x is, and x is our frequency. We plotted frequency on the x-axis. So this tells us x is equal to 1.26 over 3.40 times 10 to the minus 15. And solving this, we end up with 3.71 times 10 to the 14 hertz. So you can see that frequency is just a little bit lower than our red light. So we never actually hit the cutoff frequency in the experiment that we were doing. It would be in the infrared region, so not in the visible region. Okay, so hopefully that gives you some idea about the photoelectric effect and how to analyze data from it. There's a couple of questions below for you to try.